automatically.
Hello, hello, hello. Okay. Hi, everyone. Welcome to another user group meeting. Today at Education First, thanks to our host, Nico, who made that happen. And I have to say, it's the best setup we ever had. But anyway, it took us just 20 minutes to set it up because it was like plug in, it works. Usually we take an hour, but yeah, thank you guys. Okay, there is one thing. There's a GraphQL conf coming up. Actually, it's next week, the week after that. And don't sit down because there's a... And that is in San Francisco, so if you have nothing to do, you can still get tickets. And I think there will be an online edition as well. With this, so what's a GraphQL Zurich user group? I know I see a lot of new faces. So the GraphQL Zurich user groups tries to get people that are involved in the GraphQL ecosystem together to make you talk and even maybe introduce you to your new workplace. You never know. And show you all the cool things that you can do with GraphQL. And we try to do that by hopping around in Zurich to always have a new location for each meetup. Each meetup will have 3 talks. One is from the host, one from the community, and we also always try to get one from one of the various GraphQL companies we have out there. Today we have Marion, she's already down there, and she's from Hasura, so I'm really psyched about her talk, which is about Relay. And each talk is 25 minutes plus 5 minutes Q&A, so that's not too much of a burden to do. So if you want to talk, just reach out to one of the chilies that you see here. So every time you see this logo, you can talk to that person, and we get you sorted, and you can do a talk next time if you want to. So how can you help? As I said, you can become a speaker here. Just reach out to us. But also you can host one of these events. So if your company is doing something with GraphQL or wants to do something with GraphQL, it's a good idea to talk to us, set up a meetup with us, and this also might bring you a couple of new engineers to your company. You never know. Also, join our YouTube channel or our Twitter account for updates. All these events are live streamed, so if you missed anything, you can watch it afterwards again. So our next event is in October. We haven't decided where. Maybe we're going to host it. We don't know. But if you want to host it, you can just get in touch with us. And with that, I'm already done. And our first speaker is Nico tonight. And he's going to talk about Apollo as a client. And that's actually a good mashup between you and Marion. So you just have to plug it in.
Screen on. Screen on.
Yes. You guys hear me now? That's cool. Super official.
Ready?
Yeah.
That's not.
Where's my mouse? No, it's good. Okay. How are you guys? All good? Yeah. So today I'm gonna, like Michael mentioned, I'm gonna be speaking about building GraphQL-powered mobile apps using Apollo's caching and local state management. But before I start, thank you. Thank you for coming. I joined, I moved to Zurich in April, and yeah, my first month I came to the GraphQL meetup. I was super impressed by the work that, Michael and this team has done to organize these events. So first of all, thank you to them for organizing, letting us be hosts. And thank you all for the interest in GraphQL and for coming. And just to introduce myself as well, I'm Nico, engineering manager here at EF. So I guess first question we should ask ourselves, just so you guys familiarize yourself with the environment, who is EF? So this is our mission statement, opening the world up through education, and we do this in a lot of different ways. So if you look at all the variety of programs that we have, you could break it up into, I think, 4 main pillars. So EF language in schools. We have schools all around the world, online schools as well. So EF English Live is maybe our biggest product there. We have EF cultural exchange. So, immersing others through culture and educating others through immersion. EF educational travel. So this is the part I work on. So we focus ourselves on traveling and tours and these kinds of things. We also have our international business school in Boston. So I came from Boston as well. We have our office there, and it's more of a campus alongside a school. So just to give you some background, so again, I work on the tours or travel side of things. I work for Go Ahead Tours and Ultimate Breaks. It's our suite of B2C travel products. So we do, the typical tours that you might see even in downtown Zurich with the little flags and stuff that I think I don't personally enjoy, but so we do this organized travel, adventure travel, recreational travel, things like this. Before I jump into, how we use GraphQL, I just want to make a plug that we are hiring. So if anyone is, looking for work or is interested, come talk to me. I would be happy to chat. And so I kind of wanted to start going over how we use GraphQL in production. So this is, a very, very bare bones example of, our architecture right now. So you can imagine we have more than these 3 sets of databases, but, foundationally, let's say we have Salesforce or third-party applications, could be, Salesforce, could be anything else. We have modern-day databases, so Mongo empowers the majority of our architecture, and we also have our more legacy systems. So, legacy, not even containerized, like very old legacy DBs that we need to be able to support. And so we've kind of built this. Some of it's new, some of it's through proxy, but we have like a middle GraphQL layer. So all of these are kind of divided into a microservice architecture. And so all these, are built as different subgraphs that eventually compose into one large supergraph, and actually maybe 4 supergraphs depending on, the environment that we're using. And then these ultimately power our mobile apps, our websites, internal systems, and all that. So like I said, we have 4 graphs, including contracts. So production, QA, internal for QA, internal for production as well. We have around 60, a little more than 60 subgraphs as well. And 1,000 plus types, 7,000 plus fields. So we've been in production with GraphQL for about 4 years now. And we continuously evolve, continue to adapt, and understand and learn how to use this tool better to better support our travelers and staff. So what I'm going to cover today is more on the mobile side of things. So we have 2 main applications that we support. So Go Ahead Tours and Ultimate Break, which are 2 separate products with 2 different markets. But essentially they're both kind of within one code base. And so I guess for some good context as well, you can imagine a lot of people that we sell to, a lot of our customers are always on the road traveling. So this is a mobile app that supports these travels while they're on the road. So we deal with a lot of issues with low bandwidth or lack of signal, battery life. A lot of these customers, especially for Go Ahead Tours, are also a bit on the older market. So they have a lot of older phones too. So we need to really think about all these things when we're developing for mobile. So one of our, I think, our most important tool set is with Apollo. So we use Apollo client in particular for our mobile. And so we use their normalized in-memory cache to be able to support offline mode. So if you read through Apollo docs, it's fairly straightforward to set up the cache, but I think there's a lot that we can do in an advanced way to properly have a robust caching within our app, and that way we can persist it as well offline. So if we look at some examples, this is, Apollo client, first requests to the in-memory cache. If it's not found, it gets sent to the server. Then the server will respond properly with the correct data, and then that gets stored in the in-memory cache, and then it returns it back to Apollo client. In the other example, we'll see Apollo client requests for the book in this case, but in this case, we found it already in the cache, so it's already been requested, so we can avoid hitting the server. So this is nice for a lot of reasons, right? You maybe want to avoid a lot of network requests, but for our case, it's nice because we want, maybe it's taking, 10 seconds to get a request back because the user has 1 bar in, sub-Saharan Africa because they're on a safari. So it's important that we're able to, be able to show the right data. So if they're able to get it from the cache quickly, then we can show that. And then if it's shown in the cache, then we can return it and show it in the app. So how does Apollo do this? With data normalization. So data normalization is basically Apollo's way of storing kind of the whole cache, right? So it's a flat structure that they store. And the main way they do this is by identifying all the different objects. They combine the type name and an ID. So they use an ID with an underscore or an ID like this, normal ID. And they use these fields to be able to identify each object. So I'll show you in a second what that looks like. So for example, we have this object, right, a tour. And the type name is already specified. That's just the name of the type. We have an ID attached to it. So Apollo is going to store it as that reference. So tour alongside the ID. And that's what eventually gets looked up in the in-memory cache. And then it references that and then returns it back to the client. There's also other ways. So if you don't have an ID field, either ID or underscore ID, you can kind of customize the different key fields. So here's an example where in your type definitions, type policies, I should say, you could specify instead of using an ID, I want to identify it by user ID. So it'll combine the type name and the user ID. You can make this way more robust as well. And so you can combine a variety of different fields, not just one. That makes it easy for you to customize how you want to actually cache and identify the data. And then there's different ways that you can interact with the cache, right? So you can read and write directly to the cache without communicating with your GraphQL server. So this makes for a really interesting local state management as well. So avoiding things like Redux or maybe more, sophisticated, let's say, local state management tools or context, things like this that might bloat your app. If you're already kind of maintaining your cache, your Apollo client cache, it makes it very easy to use it as a local state management. So mutations, for example, will automatically update the cache. So in this example, if you look before and after, the only difference is the description, right? If we run a mutation with our usual mutation hook in our client app, if we just update the description without even having to go to the server, Apollo client already updates the cache normally. So the response is much quicker, and it's a better UX experience that way because you're not waiting for the server to make a response. And there's different strategies that we could take. If there's an error, obviously we don't want to update the cache and things like this. But those are all part of the optimizations we make. So here's a lot of the different caching strategies, or I guess cache APIs that Apollo gives us. So you can use read query, read fragment, update query, update fragment, which combines reads and writes. And then you have your typical cache methods like cache eviction, garbage collect, and you can modify fields directly through the cache as well. I'm going to walk through a demo at the end for all of this also, so just putting that out there as well in case anyone is confused. I'll make sure it's a bit clearer. So for local state management, again, we're already maintaining the cache, so it's a really nice tool to use so that you don't bloat your app with another third-party library like Redux or something to maintain your local state. So I think there's many ways that we can maintain our local state. So for example, in this case, you can use the client tag, client directive to tag your queries. So for example, this query up here doesn't exist on the server, but if you tag it as such, then and set the type definitions client side like this, then it becomes a client-only query. And you could do the same for different fields as well. So if you have a server-side query, you can identify fields, individual fields, as just client-only also. And then here in your type policies is where you would define, what data you actually want to return. In this case, I'm using a reactive variable to return whether or not the user is logged in, which I'll go through in depth as well for reactive variables. But you can imagine, maybe we want to store something in local storage or async storage, and we can just return it straight from here. So reactive variables is another method that we can use while we're maintaining local state. Reactive variables is basically Apollo's way to, store different variables alongside. And the nice part about these is that they will cause a re-render anytime that you update the variables. So obviously you don't want to use it for every case, but for things like a logged in user, and I'll show you an example, as soon as I update the reactive variable, let's say on logout, it'll re-render wherever it's used as well. So if if I have a Boolean that says like if the user's logged in, then show the main screen. If they're not, then show the auth screen. So as soon as I log out in one component, it'll automatically update the other component that's triggering that conditional to see whether or not a user is logged in. So I guess this is the main point I wanted to bring up. One of the best things that we do, just because it's so seamless, is to persist the cache, right? So before for mobile, you would do, maybe more sophisticated. You'd maybe use a local SQLite store, for example, and now you're managing a different kind of database or database protocols than you are on the server. I think that makes things a bit complicated on the client, and it makes things, harder to read as well. So we're using this library from Apollo Cache Persist. And this is basically all the setup is. So as you're creating your Apollo client, you create this cache persister. You have different storage types that you can use. So it could be async storage, local storage, ionic storage. I think there's maybe like 5 or 6 you can use. And then all you do when you're kind of instantiating your Apollo client is you restore it. Then on logout or whenever you want to kind of clear that cache, you call a method called purge, and then the cache is purged. So that's kind of the end of my PowerPoint, but I'll do a quick demo now as well. Yeah, I think I'm good. How much time do I have?
You switch, maybe just mirror the screen.
Yeah. Yeah, I think that's better. All right.
I'll go out of that. Just right click on it. And then mirror. Yeah.
Nice. Let's close this out. Okay. Give me 1 second while I run this. Just running Docker up. Yeah. Is that okay? Okay. I won't go in detail of the repo in general. Actually, one second. Can you answer this real quick? I think it's the food. I don't want to get you guys hungry, so I want to make sure I answer. Okay, so here basically I'm running both the server and the app locally, but what I want to show is basically just in the app. So let's start with just where we're initializing the client. So like I said, this is our function. We're in a use effect here. All we're doing is calling restore on the persister that we're setting up. The persister is set up here. We have to pass in the cache, which we're setting up normally as we would any Apollo client. We set the Apollo client, and then on this method, on this callback, we'll purge the persisted cache. So what that looks like also here. So here we have the logout method. So all we have to do here is clear the store on logout. So if I come in here, here's my basic app. There's more things I want to show here, but once I log out, the persisted cache is already removed. So now that we know the cache is getting persisted, I have a few. I guess I'll do a quick walk around of the code here. So here I'm getting a tours query, right? It's just getting back 3 basic tours. I'm mapping it into some car that I have here. Then here in the more menu, what I wanted to do is kind of show the cache. So that's why I have this JSON view here. Can you guys see this okay here? Might need to zoom in. I think it might be maxed. Yeah. But here we could see what the shape of the cache looks like. So we see that we have the type name, the ID, the name. So how this works, for example, here we have the root query. So here we have our main tours query, and it recognizes that we only have 3 objects, but instead of storing the full object here, we only store the reference. So as I said before, maybe I'll do a little quiz. Does anyone remember how the objects are identified with Apollo client? ID, exactly, yeah. So it's the type name and the ID. So we just stores a reference. That way it's not duplicating any data. If we had another query or another set of data that also was referencing a tour, as we all know with GraphQL, you can kind of nest things a bit deeper as well, so we're not duplicating any of that data. And then each object will be represented individually here alongside its reference. So we have the type name, the ID, and then all the different data that corresponds to that object. So in this case, it's just a name. So I have a few methods here as well that I wanted to show. So for example, I'll do this one. So here we're using write query. So that same query document, you can see right now we have 3 tours. I'm overwriting it with 2 separate tours, and we'll see the names are tour written by cache. So if I write this over, ignore the warning. I don't know why that warning showed up. We could see that the root query now only has 2 items, and it's referencing tour 1 and tour 2. We still have these 3 tour objects because we haven't purged that cache yet. But now we have 2 new tour objects, so both of these are the tours written by the cache. And the root query is referencing those new tour items. So even if I go back here, without having to re-render or refetch any of the data, we could see that we have the 2 new tours that I manually wrote to the cache. And so here I have another method. All good?
Yeah.
You guys will get your food. So I have another method here that's directly modifying the cache. So we're identifying the cache by the type name and the ID of 1. So that's this one here. And I want to modify the name. So instead of tour written by cache, I want to say tour modified by cache. So I'll click this button, and now we could see the cache. If we inspect it, it says tour modified by cache. And again, all this is instantaneous, right? We're not maintaining any SQLite store here to kind of update local state or local data. It's quick, you know, UX feedback, instant. And so we're not hitting the server for any of this stuff. So for things like offline mode, it's super, super nice. And then here, for example, again, on logout, I'm clearing the store, but I'll show you guys here what it looks like if I just clear the cache. Now the cache is completely cleared, right? So no more items. If I come back here, I have a refetch. So this goes back to the server now because there's nothing in the cache. And now I could see my cache again filled up. How much time do I have? I could keep going. It just depends when people stop me. Let's see, what else did I want to show you guys? So reactive variables are an interesting one. I'm maintaining here one reactive variable, which is called the current user. This one is the example I gave. This one's a nice one to use as a reactive variable because you might have one screen that's maintaining the state for whether or not there's a user. So if I look into my navigation here in the root stack, I'm using my reactive variable. That's the hook I just had there. So again, this is my hook from Apollo client, use reactive variable. Keep this open. And I'm checking if we're logged in, then we go to the main tab navigator. If we're logged out, then take us to the stack navigator. So again, this, even if I'm not on here, right? If I go into the more screen, I have a logout button. And here I'm modifying the reactive variable to be null. So I'm clearing out the current user. I'm also clearing out the cache. Once I log out, again, it triggers a re-render where I wanted it to. So that's the nice part about reactive variables. I think you have to responsibly use them, right? Because you don't want to maintain a bunch of reactive variables and then cause re-renders all over your app. So I think it has its specific use cases, but it's a nice way to maintain local state. And then the other method I have here for maintaining local state, if we go into our navigation, I have our root stack. I commented this out. So this is a query. So this is what the query would look like if I just wanted to have a client-only query is logged in. And I'll define that in my type definitions. So I can set up my own type definitions client side that the server will never know about. So here I've created a query is logged in that returns a Boolean. In my type policies is where I'll actually kind of define those and define what it's going to return. So this is the syntax for it. We'll call this read method on is logged in. The same for the current user. And so here I'm still using my reactive variable. So I could do the same thing, right? So as soon as I call whether or not it's logged in, it'll call this reactive variable of current user and check if it's null. If it's not null, then you're logged in. If it's null, then you're not. But yeah, so this case, for example, because we're not using a reactive variable, it wouldn't cause a re-render. So if we wanted to use this, it wouldn't work the same. We would log out, it would clear the current user, but it wouldn't cause a re-render to the main, to the root stack navigator. So then we wouldn't be logged out. So I think that's the benefit of having the reactive variable here instead. But I think that's essentially it. I think that's what I wanted to show. So I'll pause there. I think time for questions.
Yeah. Go ahead.
Yeah.
My first question is, do you usually write in the cache also query that normally then goes sync with the server? And story of interesting conflict?
It's a good question. Yes, there's certain tools you can use as well. So I was looking at a tool, I think it's called Apollo Link Offline, that we don't use in production yet, but it's kind of solves this problem that you bring up. It queues up, let's say, a mutation or a query that they perform offline, and then when they're back online, they'll run the query, and then it'll update the cache that way. But yeah, there's different strategies that we can take, whether or not the data is returned from the server or not. You can also set fetch policies I don't know if you're familiar with those, either on a global level or per query level. So you can, decide for this query, don't hit the cache, hit the network directly. So it depends on each kind of component that you build or your top level strategy, how you want to set up the cache to network strategy. So there's different approaches you could take. I think there's like 5 to 7 different fetch policies. So, some are cache only, network only, but some are more like cache first, check the cache before you hit the server. Then there's cache and network, which means you hit the cache, but also hit the network and then update the cache with the network response. So different strategies, yeah. Yeah. Yeah.
So I joined later with, did you show how you configure your cache? Because in Apollo you can set the expiry for the cache method. I was wondering how, do you know how does it work behind the scenes to keep the data? What will happen?
Yeah, it's a good question. Should I repeat the question? I don't know if everyone can hear. He was asking if you can configure the Apollo client or the cache, a certain expiry, or what strategies I guess you could take to keep the data fresh and make sure that there's not stale data. So you can set up an expiry, I think, on Apollo client. The cache also has a bunch of evict methods that you can set up as well, depending on how you want to use it. We haven't gone as far as monitoring, that level of fresh or stale data. We do, with Apollo Cache Persist as well, you can set, the size that you want to store. So Android, I think, is a limitation where it only allows you to store 2 megabytes. And so we kind of keep track of that via our analytics to see like how much. And so far, there's not really any bad use of the cache. But I think it's more of a cleanliness thing, making sure that you're not always writing directly to the cache. If you are, then that's when you kind of make sure that you clean up after yourself, I guess. So it's just a matter of being responsible when you're writing directly to the cache more than anything.
Mainly my question was about the integrity of the data. Because let's say, especially for the native application, you might be offline for a couple of days. And then if it starts kind of deleting some of the records that have been acquired, then how does this behavior affect the parent query?
I guess it depends. Maybe that's a similar question to what he was asking, if I understand correctly, because you could set up different caching strategies, and when they're back online, they'll requery all the data, for example. So if it hits the server and there's updated data, it'll replace that data, depending on how you define your type policies. So there's different strategies. For example, for pagination, you don't want to completely replace the data. You want to tag it on. So in your type policies, you can define how you want to merge the incoming and existing data, if that answers your question a little better.
Yes, I have also a question about the slide with the mutation. So does Apollo automatically updates based on ID and field name when you do a mutation? And then it queries the server, so it always has an optimistic update in that case?
No, you have to set optimistic response. It's a separate variable that you can set a separate option.
And then you still have to do the cache query and stuff by yourself and then replace it in the cache? Because
no. Depends. I guess depends how you're reading the data. Like if you have a network-only query, then obviously you have to refetch.
Yes, makes sense. No, my question is more like, when I look back, I haven't used Apollo in a while, and back then it was like, you can do optimistic updates, but the optimistic updates was actually a cache mutation, which then meant it's like a ton more code to write,
No, it is yeah. You do have to kind of define what you want to update optimistically, right?
Yeah.
Yeah.
Okay.
So it's true.
Okay, last question. And then we will switch up. Any more? No?
Okay. Thank you. Appreciate
Thanks.
your time.
Okay. Musst du zuerst etwas sagen? Okay, hi everyone, and thank you for joining on a Wednesday evening. Also, Michael, thank you for organizing everything. So I originally founded this meetup. Then I took a break, which means like I went to backend engineering and took a break from speaking, and then Michael kind of took it forward. I'm very happy to see we have so many members by now, so thank you so much. Cool. Today, I would like to talk about the slightly controversial topic about GraphQL without relay is not worth it. Yeah, I would love to have discussions later with kind of a slice of pizza and a glass of wine. I'm Marion. I'm head of developer education at Hasura. And in my free time, I like dirt biking. So if you know about dirt biking and want to have a chat, let me know as well. As I said, I'm working at Hasura. I'm leading the documentation and the technical evangelists team. And who knows about Hasura from here? Okay, so basically Hasura allows you to build production-grade APIs on all of your data sources. So in the back, you can have any kind of database. And then Hasura exposes an API for you, including resolvers, query mutations, and everything that you need. Now, I'm here to talk about kind of a problem that we had in Hasura and how we solved it. So if you know Hasura, you know that this is the Hasura console. Now, a Hasura API you can kind of contact in 3 different ways: the API, the CLI, and through the Hasura console, which is mostly used for testing queries and for adding event triggers, remote schemas, and actions which are used for business logic to extend your GraphQL API. So we had the problem that we wanted to scale our UI development, which means like we wanted to have parallelized development with different UI teams. So then we hired more developers, but this actually didn't solve the problem. It actually made it worse, because more developers working on UI components and then kind of breaking each other's components. Does this problem sound familiar with, can somebody empathize with this? Okay, so anyway, as the team was growing, we are now almost 200 people. So it kind of obviously the UI team was growing as well. And yeah, we didn't solve it by hiring more people. And we were asking ourselves, how can we scale our UI development without kind of breaking each other's components? So the first version we were thinking of was independent micro apps. But this turned out not to be an option, because if every section of the UI has to load their assets independently, it results in too long of a loading time. And also, if each component makes its own API call, then there's a lot of redundant data fetching, which kind of reduces performance. Even the worst case that can happen out of this is if you switch a tab, there will be a reload because it's actually a different application in the background. And if you go through the root component, then you have to coordinate with humans, which is what we wanted to avoid. Like, we wanted to have completely separate UI teams. Yes. Then the second option was that we have one application, but each team is responsible just for specific components. This is very hard because there's a lot of shared states between these components, and the global state store gets modified by multiple components, which means like if the top component has to pass down data to the child components, it can cause regressions because different components are modifying the parent component. So yes, and the data fetching responsibility will always be with the root node, which always has to be changed by multiple teams as well. So also this was not an option for us. Then we discovered Relay. Who has heard of Relay? Okay. So Relay is used with React, so it's actually a data management library for React. And the idea is that each component has an owner. So you can see here the green, it's not dots, it's like vertically, are quarters are React components, and the yellow ones are are GraphQL fragments. So basically, the data responsibility and the data requirements are defined right at the component. So everything is very close together. And the way this works is that the relay compiler, which is the very top thingy outside of this whole diagram, it creates a big query of all of the these components, including the children. Whenever some component gets updated, this compiler updates everything, which makes sure that we have consistent state, and which also allows teams to work separately. Now, we haven't found any other data fetching technology that solves this problem. If you have, please let us know, because then we can use it as well. So there are some challenges that we faced when we used Relay. So Hasura supports a lot of data sources, obviously all of your databases, but also actions, remote schemas, event triggers that are used for business logic. And the Relay works with a global node ID. So for tables, this is very easy because all the rows have unique identifiers where you can use the global node ID of Relay. But for something like actions, this is not so trivial. So we had to implement this for these non-trivial data sources as well. Also, the Relay schema is a little complex for onboarding, which is why I think this is the main reason it's not used more widely. So because they have a little bit of a complex connection spec for pagination, etc. Now we want to make it easier for ourselves, but also for the community to use Relay. So what we're doing is we're dogfooding Hasura, which means like we're implementing the Relay spec on our Hasura server for our console team to be able to use a Relay approach. And we also open source this to the community so that people can use Hasura with Relay out of the box. As I said, some server support is already present for tables, but in the current version V2, it's not supported across all of the data sources. But in 2 weeks, we have our new Hasura version V3 come out, which is also called Data Delivery Network. Now, a little bit about this. So the idea is that there will be a super graph across all of your data sources. At this point, you will be able to use any kind of data source for your supergraph. Until now, Hasura supported a few databases like Postgres, SQL Server, MySQL, and others, but now we work with a connector approach, which means there are some database connectors like MongoDB. Now we support some vector DBs for AI apps as well, that you can use these databases through a connector, which means you can also build your own connectors, and then it's kind of unlimited, the data sources that you can use on your API. The goal is also, it's not the goal, it's already implemented. We have full Relay support for all of the data sources, and we will work with the Relay global ID to kind of connect every one of our data sources as well. Also, Relay supports cursor-based pagination, which Hasura supports too. So there's a lot of things that we already have in common, and we just want to simplify the spec outwards for the community to use, and as I said, also for our front-end team. Now, there's 2 resources. I don't know if the slides will be shared later. We have a blog post that we launched exactly about this topic, why you should use Relay for scaling UI teams, and also the new Hasura version called Data Delivery Network will be launched very soon. Information is already on our website. Now, thank you so much. I don't want to do a big Q&A now because I would love to have a longer discussion with people who are either interested in Relay or have solved the UI problems in their own company so that we can learn from you. Also, I'm hiring a technical evangelist to build data connectors. So if you're interested to work for Hasura, also let me know. Thank you so much.
Awesome. So we are just switching up. Then we have one more talk. Yes. Because they're setting up the food. I saw like there's a ton of food. I think like 10 pizzas and even more. No, there's more. There's more.
Big pizza.
There's more, yeah. Like it was like a car stacked like this high.
That's good. And I now have more time. Take it.
So here's your mic.
Yes, one thing after the other.
Because also for the food, we are going upstairs. They have like a terrace.
It would be better to come down again, right?
Yeah. So put it on, push the red button,
I will one thing right
and then you're online.
No pressure.
No, I'm just showing the people online
Ah, yeah.
how slow you prepare.
Well, you told me I have 10 minutes. Just need to think something quickly. 1 second. There we go.
Okay, let me see if we have your screen. You also have to plug in, just by the way.
Would be good, you mean? People would actually see something. I can also do it here.
Okay.
1 second, 1 second. There we go. Good. Let's make this full screen.
Looks good.
Looks good.
Yeah, it's already behind you.
Nice. Awesome. Cool. Hi, I'm Pascal.
Is it on, Pascal?
Yes, I believe so. Maybe it's...
Yeah, it's good.
I mean, you know, the speakers are a bit bad, but anyway. It sounds better here than it sounds while sitting there, so for you. A good way to motivate people to have a talk. You actually hear yourself better when you stand in front of the people. Today, I will talk about how you not break your GraphQL clients. And we'll first start with a little introduction about the GraphQL schema. It's probably the most important artifact that your GraphQL server produces and your GraphQL client consumes. And in the modern day, you probably not only have a browser which consumes your API, which is nice with GraphQL. It's super easy to have multiple clients. So you maybe also have a mobile app, you maybe have a watch app, and some people do even plug their coffee machine into it. The nature of such a GraphQL schema is that it evolves over time. So when you have new features, you add more stuff. So your GraphQL schema grows, and the new features can be added to the clients. But sometimes you might see something like this. You see a typo, and as a backend developer, you don't really care about the apps. You think, you know what, I will just fix it. And once you fix it, you break the clients. And this happens really quickly by accident. And I will have a little demo prepared.
where I can show you how easy you can actually break this to-do app. So this is the demo app of today, and it totally didn't take me longer to build this than prepare for the presentation. You see we have simple to-dos, and you also see the author of the to-do here, and you have some status, which is, we got a new requirement from the business with all the AI hype. They also want to have AI to-dos. And the AI to-dos, they will basically just not display a username here, and will be generated based on the weather, I don't know. Anyway, if we go to our server implementation, we use hot chocolate, so this is our query. And the schema that's put out behind the scenes is this. So we have a query which returns to-dos, we have a to-do, and we have this enum. So as a backend developer, you probably go into here, and then you say, you know, this to-do, this is now nullable. So let's make it nullable. I should really have brought my keyboard. They've been a lot easier. Like this. And then we just use the AI, and we get an AI to do. And when we restart our server, so think about it, we did the change, we wrote the tests and whatnot, and now we publish it to the server, and then we get an issue. Because now we have this. The client app is broken. And why is it broken? It's because a property now is null. And when you investigate why this happens, is because we now changed this to be a nullable type, which then has the effect that the AI to-do doesn't have an offer and just returns null. And this then means that when the client app, which is correctly implemented, and expects the created by to be there, because it's not nullable, and we call to lowercase on null, then the client explodes, which is not nice. So what can we do about this? As a backend developer, there are a few things that come to mind. And the easiest thing to do against it, where's my rider? There's my rider. The easiest thing to do against it is something that we stole from the UI developers, a snapshot test. So what you do is you basically initialize a server in memory, which has the same configuration as your actual server. Then you print the schema, and you create a schema snapshot. And then you have this file, which is the snapshot file. Now, when we run this test, we'll see that will fail. There we go. Let's make this a little bigger. And we see that the snapshot do not match. And we immediately see that, oh, no, I have to scroll up a bit more. There we go. We immediately see that there was a change in the schema. So this line was removed, this line was added. And we see that the nullability of this field changed. Whatever you do, I would strongly recommend to have this as a backend developer anyway. Whatever schema, whatever prevention methods that you use to not break your client, always do this, because it's really nice when you have a pull request and you review the pull request, you always see what's happening on the API level, because that's something that's, especially in bigger pull requests, a bit of a challenge. Good. So you can use this as a prevention method to prevent breaking schema changes, but it has a few flaws. So one flaw is it doesn't scale. When you have a big schema and you have a big feature that you implement, then you have a ton of changes. And then it's just one exclamation mark that you might miss that then breaks the client. And then it's really difficult to teach this knowledge to the whole team because, third point, GraphQL changes are really complicated. And I have a little selection for you. You might think, that it's obvious that when you change nullability, that you break the client. But what do you think about this? Is adding an enum member in the GraphQL schema a breaking change? Who thinks yes? Hands up. Yes, exactly. Both people are right. It could be. So there are three categories of changes in GraphQL. There are non-breaking changes. This happens when you add an output field, because if no one requests it, then it also doesn't break a client. You add a new type, or you add an argument to a field, but only when it's either nullable or it has a default value. And there are more. I only have a few little selection about it. Then there are dangerous changes, and there it is, enum member. So what's a dangerous change? A dangerous change is technically not a breaking change, but there are clients that break. Because, for example, you don't know how to serialize it. When you have a strongly typed client in Java, C#, Go, whatever, and you get something back that you cannot deserialize, then what do? You blow up. The JavaScript clients, or Relay, haven't used Apollo in a while. Relay has, I think now by default, it's enum member future-proof. So when you emit your type definition, it actually specifies always an additional type, which is the future value added type, so that you can actually deserialize it. But you can deactivate it, which I have done in the other app. So when we would add an enum member, it would explode as well. And then we have breaking changes. And breaking changes, if you remove any field, it's going to be a breaking change. If you remove any argument, it's going to be a breaking change. But also if you remove an executable directive, it's going to be a breaking change. If you add a required input type, input field, it's a breaking change. So it's a lot. It's a lot. And everyone that reviews a pull request has to have this knowledge. Otherwise, you're going to risk that you break eventually the schema and therefore a client. Good. So is there a better way than just using snapshot? Well, you guessed it, there is. It's called the schema registry. And the schema registry is an application that runs as a service, and you send to the schema registry your schemas. I will come to deployment and integration later. And you send to the schema registry your schema. The schema registry then processes the schema and then emits a report, like you're good, you may be good, or you have broken a client. And you integrate this really deep into you integrate the schema registry really deep into your development flow so that you get early feedback. So for example, in a pull request pipeline, you validate the schema as soon as the pull request is open, because if there's a breaking change in it, then you don't have even to build or test it. And in the release pipeline, you first build it, then you upload the schema, and then you publish the schema onto the stage that you want to deploy, because it could be that it still fails then. And after that, you deploy your service. With this knowledge, let's think about how this actually works with the schema history. Every schema that you push in your release pipeline to the history will be appended to a stack of schema. It looks a bit like Git, and it also works a bit like Git. Then you have, to your schema history, you probably have multiple environments. And these environments, they can be in different versions, meaning that some might be, development might be further ahead than production because you deploy development twice a week and production only once a week. Now, when you publish a schema to a stage, then it basically appends this schema to the history of this stage. And you'll also see that the history can be different depending on what was on this stage before. And we can have a little look at how this works. So let's go to here. We use Banana Cake Pop for the as our schema registry. For this, you need an API, which I can. Maybe, if I know the key binding. Yeah, Command Shift plus. No. Oh, I can zoom in the stages. Okay, so sorry if it's too small. You can create a new API here because you need an API. where you create then stages on. And we have this example API, which is actually our to-do API. And this API has two stages. We have development and we have production. And development is in version 0.5, and production is in version 0.5, because we are worried to deploy version 1. Good. So what we use to publish the schema from the CI pipelines is our CLI tool, which is called Barista. You see, as usual, we like names, strange names. So what we do is we can just go here and then execute this script. Don't worry, you will see what it does. There we go. So what this does is it takes the schema snapshot that we anyway have, and it uploads the schema snapshot to Banana Cake Pop with the tag. This is what you do when you have a release pipeline. So we do this. Let's hope we have internet. Oh no. Then let's do it manually. So let's take this. Actually, let's first make a breaking change. So we remove created by. Now we have a snapshot. And now let's do a breaking change. Let's publish this. It was a lot easier on the big screen, so bear with me. There we go. So now we have uploaded the schema. It's not published to any stage yet. And now the release pipeline, so the pull request was merged, the release pipeline ran, and the build is complete. We have published the schema, and now we have uploaded the schema, and now we publish it. So let's have a quick look at this file, because it probably doesn't work. Go. So what we do now is we publish the schema to the stage def. And the schema registry will tell us, you can't do this, because if a breaking change, and the type is actually not nullable anymore, and it knows that because the validation rules that are there, that this was a breaking change, and that you should not deploy this. You can always overwrite this, obviously, and say you want to force this. And when we then go back to the schema registry, we see that we have deployed a breaking change. We see the history of what happened in the past. We can also see the schema and the difference. So this is just a tool that helps you to keep your schema from breaking your clients. Good. So good. So long, so good. I think I have everything for this demo. So, you know, when you now think about it, that the schema evolves and your clients evolve, and at some point you probably have fields that you don't want. It would be really annoying when you couldn't deploy them anymore because you removed the field. So what do you do when you want to break the schema, when you want to remove a field that is no longer used? And how do you even know if a field is used or not? Well, the schema is just half the story. There is something more that we have to look at. We saw in the beginning that GraphQL API usually has more than one client, or it's really common. And these clients have different requirements for the API. So they use different queries, different mutations, so on and so forth. And these clients are always have to be valid to the latest schema of the stage that you deploy the client to. So for example, here we deploy mobile to development, so it means that the version v1.17 and v2.2 have to work with the schema 0.6. So you see the client developers are a lot more confident. They are already in version 2, and we are still in version 0.6. Now, a mobile client is worse than a web client, because a web client you deploy. Once you have deployed the client, the new version is active. A mobile client has a range of versions that have to be supported. Means that, for example, you support 3 versions back, so V1, V11, and V17 have to be supported. And this is just one stage, because you don't really, I forgot this slide. When you publish a new schema, you always have to verify against all these client definitions, right? And to make matters even worse, there is a different stage. So you have production. And on production, it could be that a different client in a different version is active on a different schema. So when you think about this, it's really confusing. And I feel you, because it is. But it's also how you work, because the web team basically is a different team maybe than the mobile team. And it could also be that the backend team never talks to the UI people, which I see happen often. And for this, there is as well a solution. We also use Banana Cake Pop for this. You can also have clients in Banana Cake Pop. You see, this client has 4 versions. They're not deployed yet on any stages. We'll do that in a second. And it also has a web client. And these clients define operations like these, right? Where you see queries that they use in their versions. So how does that work? Every good GraphQL client can generate a file or multiple files of your queries that are used in the application. And usually you hash them with MD5 or SHA or whatever. So you have an identifier and a query. And you can take this and upload this to the schema registry. So let's see if the other prepared script works. What we do is we, again, build pipeline. We upload the file, the persisted JSON file, and we upload it to a client with a specific tag. So let's hope that works. It does. And what we then do later, once we release the client, is we publish this client definition to a specific stage. So let's do this as well. Client version was not found. I mean, it worked partially. I count this as a win. So I believe I probably messed this up. Yes. I only changed one of them. So let's do it like this. That should work. Now we publish the client, and we have successfully published a client. And when we refresh quickly, then we see that we now have a client, 0.3, which is active in the stage def. So what happens if we now go back to the editor here, and we say, you know what, let's just remove this field. And you've seen that the pull request pipeline, in the pull request pipeline, you don't upload a schema, because in development, you don't want to pollute the server with some information that a single developer needs. So what we now do is we basically just, let's hope it's in the history. Ooh, it is. We validate the schema. So instead of uploading it and publishing it, we just give the path, and we say we want to validate the schema that we have here against def. And when we do this, we now get a different response. So first off, it says that the field was removed. That's good. But it also tells you, if I scroll up a bit, that there was an error on the client web, and that this query failed because the field doesn't exist on the type, which is really handy. This way, you can make sure that in all the interleavings that are possible on publish, every time your schema will work with your clients. You can also have multiple active clients, multiple active schemas, because that's just how the world works, apparently. And there's no way that communication can solve this problem. The client flow has something which is a bit different. After you have uploaded, published, and deployed the change in your build pipeline, you know, on DevOps, the green deployments that you can accept manually or in GitHub Actions. You will probably also want to have a step unpublish, where you can say this client is out of support, and then you just unpublish the versions, and then you can remove the fields. That's actually how you would evolve your schema in theory. So you deprecate the field, then you phase out the field from the client, and then you remove, in the end, the field from the client. And this is all possible without having to worry about breaking your schema or your pipelines. Good. I think that was it. So if you have any questions, I'm happy to answer them. Yeah, yes.
You mentioned like 3 different ways to break your schema.
Yes.
And how do you address the enum breaking change? Because in these examples that you showed, they were mostly about like a field being removed or like nullability or the data type change. But how do you like kind of define compliances of like?
Well, it's all based on what you have deployed, right? If you have all your clients, let's say it's the best state that's possible, meaning all your environments have a schema registry, all your clients are in a client registry, and these are connected together. The best case is that the schema defines itself. So you publish the enum, and then the schema is defined, so you don't have to worry about it. Now, the thing is, how do you react to dangerous changes? Depending on what clients you use, you may want to treat dangerous changes as breaking. And luckily, there is also this command. You can set the dangerous changes to breaking. So if you know that your client will not be able to handle it, which I heard some C# clients have an issue with, then you have to set this to true. And you can also toggle if you want to allow breaking changes, meaning the thing I've just talked about, that you basically are able to completely omit the schema validation as long as the schema compiles, and only use the clients to validate that your schema is still valid. Does that answer the question? Kind of. Okay. Any more questions? Yeah, please.
One more question, but it's not really about this barista, it's about the snapshot testing. Can I ask you for?
Pardon?
I think there is an issue between the Windows machines, like when you create a snapshot test on Windows machine, the way that the Rosaline code generator structures the schema and also the new line are in Windows are different. And all of these things are.
No, that should be an issue.
I mean, we did have issues with snapshot testing before on Windows, but that was
years ago.
Yeah, I mean, usually when you do snapshot testing, when you snapshot an exception, you have the stack trace, which is the path of a person. So it could be that you know, they are on their machine snapshot, and then they publish it, and on your machine you have a different profile and a different username. So this schema, the snapshot does not match. But easy enough. That's, you just ignore it in the snapshot thingy. I mean, this is uninspired from what we do with Snapshooter. If you want to use this library, this is a bit of an adapted version that we use in hot chocolate. It's called Cookie Crumble. It's not really official, but we still publish the package, so I just used it because it really prints the schemas a lot nicer.
Yeah, but just new lines are not a problem. But the ordering can be a problem on your compiler if you infer from C#. But there is a setting in this hot chocolate specifically. There's a setting in hot chocolate to order it by alphabetically, the fields, and then it's always the same.
Yes. Reflection is not deterministic. And people often ask us why we don't sort alphabetically by default. Well, it's a GraphQL specification. So you return the fields in the order that they are defined. Well, now when you use schema first, you're fine. When you use code first, you're fine. But when you use the reflection-based approach that we use here, you know, that we actually infer and then reflect, then it can be that the underlying system, in this case C#, doesn't have a deterministic order, so it could be that it fails. And it also hit us. We were not really expecting it. Okay, yes, please.
You mentioned the problem of several clients.
Yes.
Wouldn't like backend for front end, right? When you have like separate backend for each client, would actually solve that issue?
It would make it worse, actually.
Yes, I kind of agree. So the thing is, the snapshot that you have on the schema, you know, the schema that is deployed is your point in time. So you have one point in time where you know the schema has to be like this. But you have, even if you have for mobile and for web, you have different backends, you still have multiple clients which use this. So when you do the phase out that we have in the presentation, well, I'm not going there, but in the end, when you see that you actually first deprecate and then phase out and then remove, you don't really know which clients are already or still using this field, you know?
In the version of the client, or?
Yes, because you have multiple versions of the client which are deployed, right? Which are currently in use.
Yeah, but we're not speaking about the one client, like one type of client, let's say one mobile application, we have three versions, and that's
So the issue with the BFF pattern, there's a couple of talks, I also have one on this, is like Netflix originally used the BFF pattern, right? And Facebook was also, when they started creating GraphQL, looking into that. What's worse with the BFF pattern, for instance, look at Netflix, they have like 8 device types or even more. And now you have for each of them a backend for front end. And behind that, you have maybe a lot of microservices or other services because your BFFs are just for sales. When now a developer makes a change in one of these subsystems, they don't only have to check out the clients, they have to update the BFF, update the client, and you now have a chain of, in your DevOps pipeline, which is really, really complex. Because you cannot change that always, right? You do a change in your subsystem, and that actually goes into all the BFFs that you now have to fix. And then you have to fix all the clients if that was even a breaking change. So it's even worse.
Yeah, but I mean, even if you do this, imagine if you emit queries here, right? And you emit queries here, and you emit queries here. If you have a big app, these are hundreds of queries. And so you would have to track manually hundreds of queries and what fields they use so that you can, because this point in time is not the one that you have to look at. You have to look at the whole range. So even if this is a BFF for the mobile app, it could still be that an old version uses a field that you actually want to remove. I mean, if you only do additions, you're fine anyway. I mean, depends. If you only do object type additions, you're fine. But if you want to evolve the schema, then it's a tool that you probably want to think about. Does that answer the question?
Yeah, it does. Actually, I have a follow-up question. It still seems like circumventing the issue. Like we wanted to become, we started GraphQL with schema first, right?
Yes.
Yeah.
And now we are in the position where we change the schema. Other guys don't know about it, and that's the opposite of what GraphQL was supposed to be. No, so we have that issue, and now we're trying to find the workarounds how to fix that.
Yes. Yes. I believe that it goes into the right direction with this, because you will not be able to change the schema as a backend developer without validating against all the known client deployments. So you can evolve the schema as a backend developer, which you should and you have to, because the app ages, it gets bigger. But you can prevent the issues of breaking other clients because they will get notified. So
that would be like this approach
talks.
Yeah, it's basically what I would do. And like, first of it, schema first is not really a thing, or was never a thing. Like when Facebook created GraphQL, they created GraphQL from a hack server. So hack is a PHP version, and they actually infer the GraphQL schema from their code. And the schema they only use as a discussion platform. So it's more for reading. So you can discuss with your client developers what changes you're going to do. So from a spec standpoint, GraphQL is not even designed to be written in a schema-first way. If I introduce GraphQL at larger companies, it's more like start a schema guild. And in that guild, you have like client developers and backend developers. And that's where you talk about how you're going to introduce things to your schema. And that's also what Pascal said with talk. Talk with your front-end devs, how you're going to introduce something. One thing what you also should always have in mind, don't introduce things just in the schema because you in the backend think this might be a good idea. Like there should be no thing in the GraphQL schema that doesn't have a client use case. GraphQL is thought to be client-centric. So don't introduce just some random fields because you think in the backend you know how to do that. It's always a discussion between front and backend engineer. And that actually is the good thing because when you think about with REST, you always had these iterations like you would also talk. And you would say, okay, I need this feature. And then the backend engineers went back, built that, show that to the front-end engineers, and it's that's actually not what I wanted. And that's where the schema as a discussion is a good thing. So you can together already huddle around that, discuss what you want to do, then you implement it in the backend, and then you have fulfilled that client need.
Yeah, so in the end, you still start with the schema. But you don't use the schema as necessarily as a definition. It's just you define the contract together, if you can.
It's like, yeah, and this is also great. Like maybe you don't even look at the whole schema. Maybe it's just the part that you want to change. So you just have a scribble block and you start with your front end engineers and discuss it.
Do you have GraphQL like? I mean, how big are the teams? Yeah. 13.
Yeah.
Right. So if you have only 2 or 3 guys which are really into GraphQL, really like it, and they do the discussions for the rest of them, that's already enough. It's important that you have like good people that know how GraphQL works, and then they should sit together with people that know how the domain works, and together you actually make a schema that works. But
yeah.
Eventually, you will have changes in your schema that you want to remove.
And I really would just do the thing that you want to implement, not the word.
I mean, it's like the story that every hot chocolate enthusiast faced. It's so easy to expose. You know, you just return. So you write the resolver, you return an object, and all the properties are exposed. It's fantastic. Until the moment that you realize, now I want to rename something, or I want to hide something from the API and whatever. And then there's always the client guy that has already used it somewhere in the UI, and you don't get it away for the next 3 months, right? Okay.
Okay.
Yes, please.
Yeah, I didn't quite get to, why you need to have the schema version speak first. I do understand that you mentioned like auto repository. So is there some kind of benefit to registering it in one single place? Current default version in this environment is compatible with this client.
Yeah, so these are things. Can you go back to the? So when you look at how these things stick together, we have an API here, and this API, this view is actually from this API, right? And these stages that we defined here are attached to this API, and the client is always a consumer of an API. So all of these things are connected to each other. meaning that as soon as you deploy or publish a client, it's going to validate against the knowledge of the schema registry. And the more you put into the schema registry, the better your understanding becomes of what you can do and what you cannot do. I mean, soon there will be metrics in this tool as well, where you see your requests, and you resolve usage and everything. And when you then have everything in one place, then you just have to visit the schema registry, the client registry, or banana cake pop to see which fields are in use, how often are they used, which are slow resolvers, which are fast resolvers. And this is a tool that basically makes you scale your GraphQL story, because at some point you will run exactly in the issues that we discussed, right?
Well, the question, can I remove this field now? It's one of the most questions we have. Like, I did the rename, I've had a new field, can I remove it? And you just go in here, you search the field, and then you see which client is using it and how often it's used and things like that.
So what about type safety?
Yeah. Yeah.
Yes, but what usually happens is that you are in an environment that is something like this, where when you regenerate, you can't change these. They are already deployed, and they will be supported because people don't, I mean, I'm the guilty one. I don't update my iPhone apps every 2 days. So I'm the one that's still sticking on V1. So I'm the one that now you cannot provide a new type safety. As soon as you have published, I agree. You will regenerate, and you will know exactly what stays you. You also, in web, if you deploy everything together, if you have a Node app, for example, and in this Node app you have a GraphQL API and you have a web app, and you ship every time everything together, then you don't need it because you have type safety. But then the other question is, then probably you also don't really need GraphQL. You can just use, I don't know, gRPC or something like this, right? Or Next, I don't know. Yes?
I understand the schema stuff is very good, but how do you track how often it's used? How does it work?
Well, the thing is that we know which fields are used in the queries. So we can validate the queries. So no, it's all open. I mean, at the moment, what you've seen is without any tracing at all. But the thing that's in the making and will soon be released is all based on OpenTelemetry. So you just add another OpenTelemetry exporter, and it sends it as well to the ingest. And then it tracks which resolver is slow and whatever. But optimized a bit for GraphQL. So you... Yeah, I hope not, but that's, you know, that's, you shouldn't lock that. Yes.
Last question?
Yes, please.
One more question, when you mentioned how often, and we were talking about the replicating, is there any kind of, like, can we connect with telemetry data?
Yes, in version 10. Yeah, it's already on the, we already have insider previews, but it's not yet fully polished. So in the next 2 weeks or so, yes.
Yeah, and I said it works with OpenTelemetry. So you just plug the OpenTelemetry exporter in, send it as well to your logging system as well as to us. We just extract. Cool.
Very last question.
No, you can do whatever you want. We have actually, just because we can, we do have a very good example. Oh, that was wrong. We do have a very good example where we do exactly this. I need to switch the workspace quickly. So I think it's nope. It's Vue, but yeah, it's not here. I don't have it.
You can go back to the go to the ChilliCream. There. Go to ChilliCream.
This one?
Yeah.
Oh yeah.
Yeah, go on the shop.
Ah yeah, there you go. So you can have everything. So it's no semantic versioning. We don't infer. It's basically when you push the thing, because we expect you that when you deploy, before you deploy, you publish, And we expect that these two things are really close together, because otherwise the whole system doesn't work. So that's the thing. But you can use whatever you want. Also for the queries, by the way, the MD5 hash, SHA hash, it's not validated because there are a lot of clients which you still have to, polish manually to support this. What I forgot to say is, if you have, I'm done in a second. Don't worry, you get your food. We now have these published operations, where you can inspect what the operations are published, what queries you use and whatever. And you also see this ID, and this ID is the same ID that we have in this persisted JSON file. What you can do is for every production API, recommended anyway, is that you use persisted queries, because the easiest way to make your API secure is when only the queries that you defined are executable. Then you can also use the schema registry for this. So maybe this also helps you a bit to understand why you can do it. You can just connect your hot chocolate server to this schema registry, and it will automatically fetch the client by ID. So you just send over a persistent query, for the ones which don't know, is you only send this ID over the wire, and the server infers from the ID what the content of the query should be. And this way you can secure your API pretty easily. Yes. Cool. Thanks for listening to this. And if you have any more questions, we can discuss over a beer and some pizza. Thanks a lot.